Good afternoon, everyone. You're welcome to today's class. Today's class on Quick Notch online tutorial. Last time we talked about the other two theorems where we have angles on the same segment are equal. Angles on the same segment are equal. We also talked about opposite angles of a circle quadrilateral as supplementary. Then we talked about angle at the center is twice angle at the circumference. But today, we want to proceed to another theorem, and we are taking two theorems today. And the first theorem is exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. We will take questions on that. So this is a cyclic quadrilateral, and we have a circle and we have a quadrilateral inside it. So what this theorem is telling us is that if you have this kind of diagram, this extension here, the angle outside the line is the same thing as the angle rightly opposite inside the angle, inside the cyclic quadrilateral. So that if this is 60, this must also be 60.
60.
So the other theorem we want to talk about today is angles between a tangent and a chord through the point of contact of the tangent to the circle are equal to the angles in the alternative segments. I know some of you don't like this. Oh, it's too long. Yes, the summary of this theorem is angles on the alternate segments are equal. What am I talking about? If you have a circle and you have a tangent, I hope you all know what is tangent. Anytime you have a circle, any line touching the circle is known as tangent of the circle. So we are saying that if you now have a triangle inside such circle, an angle on this side of that line must be equal to an angle facing inside. Look at this line now. This is a chord. This is a chord, right? The angle that is touching this chord will not be equal to any angle that is lying on that chord. It will be equal to the one that is outside of it, as in not on that very chord. So this will be equal to this. Let's assume this is x. So x will be equal to y. So also on the other side, this is another chord. So this angle here will not be equal to the angle on this chord. It will be equal to on another angle. I think this is A, this is small b. So also angle A and angle B is equal to each other. So let's take question to make you understand these two theorems better. So we have this theorem here. So these are past questions in Y from Y past questions to make you understand these two theorems. So look at this question very well. Like I told you in the previous class, that if you want to solve any circle geometry question, let's look at the diagram properly. Let's do what? Look at the diagram properly. We are looking for what here? CDT. Don't disturb the original diagram. Draw another one. So that you can scatter it on your own. Okay? This diagram, I have a tangent. I have a tangent. Also, in this diagram, I have a small triangle. See the way I'm bringing it out one by one. Don't just complete it, bring it out one by one first. So this is D, this is C. And before I can find CDT, I have to know that, okay, apart from that, I can also see a triangle. Let me draw that out. Can you see this triangle? I brought this triangle ACT. But this triangle have an extension here. So this is 37 degree, this is 43 degree. So we know that if we have a triangle, any line extending from that triangle, it will be addition of these two opposite angles. So I'm going to start with this. I will say that B BTC is addition of these two angles, addition of angle A plus angle C. Why am I saying that? I will say exterior angle of a triangle. So that means angle A is 37 plus 43. 3 plus this, 10, remainder 1. 3 plus 4, 7 plus 1, 8. So our BTC, that is not what we have to calculate, but we actually need it. So I've gotten this side now to be 80 degree. But I'm looking for this side first. I can now remember that anytime I have a triangle inside a circle and I have a tangent, then I am free to say that the angle that is produced outside of this chord will be equal to angle inside the alternative chord. So therefore, angle B, or let me say this is B, this is T. So C, T, okay. We are looking for C what? C, D, T. So we have gotten C, D, T without wasting time. So therefore, C, D, T, C, sorry, we have angle A, we have angle B. Okay, that is still our BCC. Now, this place now, you can now say that CDT is equal to CTB. CTB. And what is CTB? 80 degree. Or you can call it BTC to make it easy. So therefore, our CDT is 80 degree. So we have gotten this now to be 80. So what are we left with? We are looking for CTD. There is CTD. CTD, which is this place. So you don't need to stress yourself. Just bring out the triangle I'm seeing here. I have G, I have C, I have T. This is 80. We are looking for this place, and this is 43. So sum of angles in a triangle, which is 80 plus 43 plus angle T, will give us 180. Please don't forget to put your reason for this. Why do we say this is equal to this? Our reason is angles on alternate segments. Please don't write angles on the same segment. That's a different theorem. This one is alternate segment. So that is 3, 123 plus T is 180 degree. T is 180 minus 123 degree. 3 from 10, that is 7. Remainder 7 here. 7 minus 2, 5. 1 minus 1 is 0. So our answer, which is for CTD, is 57 degree. I'll take one more theorem before we round up on this. So this one is taking care of the second theorem, which is angles on the alternate segment are equal. But let's go to the one that take care of exterior angle of a second quadrilateral is equal to the interior opposite angle. Look at this question properly. And let me tell you one thing. Each time you see a question on circle geometry, check properly to be sure which theorem goes with it. Don't just adhere to the question. So looking at this, because I am seeing a cyclic quadrilateral, the triangle, the rectangles, all the vertices are touching the circle. That makes it a quadrilateral, a cyclic quadrilateral. So a line extending from it. So this outside one must be equal to this inside one. So without stressing yourself, y is equal to 85 degree. And if it's a theoretical question, you have to write your reason, which says angles on the exterior angle of a cyclic quadrilateral. So you can see this is so fast. We have gotten our answer. So if you have more question, I'm expecting your question in the comment section. And you are free to join our online class. If you're praying for WAEC, champ. We also have section for junior category, those that pray for junior WAEC. We also have a session for those that are preparing for common entrance. And we promise you, you're going to enjoy our classes. Thank you.